Hi, my name is Olivia, and today we're gonna talk about self-driving truck. Do you know that autonomous truck is starting rolling into our life? At this time, we are confronted with a significant obstacle in the process of creating, administrating, and optimizing this system for the constantly evolving products. This article will walk through the background and rapid developments of autonomous truck and how the self-driving truck system is trying to integrate into the existing system we are living right now in a couple different aspects. Firstly, it is critical for us to understand why the world we live in today require the incorporation of auto truck system into our existing system. So what is autonomous truck? So autonomous truck are commercial vehicle that use artificial intelligence to automate everything from shipping yard operation to long-haul deliveries. This technology uses long-range, high-resolution sensor, a range of deep neural networks, high performance, energy-efficient compute to improve safety and efficiency for everyday logistics. So, why we need self-driving truck? These intelligent trucks may be the first autonomous vehicle to access public roads at the scale contribute to the industry factors such as increased delivery demand and driver shortage, as well as straightforward operating domains such as motorway. As transportation business seek to autonomous technology to keep up with expanding demand, autonomous trucks are heading the road. Finding the most efficient approach to transfer control of trailer from machine to people is currently our top priority. According to the American Trucking Association, there will be shortage of 80,000 truckers approximately by 2022. Experts predict that the trucking business will acquire more than 160,000 operators by 2030 if the current pattern continues. Not just the pandemic, but both the supply chain crisis and truck driver scarcity are all contribute to significant delivery bottlenecks. The fact that the trucking industry is struggling through driver shortage has increased the levels of interest in truck that are empowered with artificial intelligence and have the ability to drive themselves. The owner and executives of motor carriers recognize that there is untapped potential to increase the operation efficiency, safety, and productivity of the business. For many years, various tech companies have been putting self-driving trucks through their places in the real world. Though humans currently occupy the driver's seats, experts predict that by 2030, automobiles will be fully driverless. The goal for the autonomous truck is to do what is called the middle mile in logistics right now. And this means getting online order from a fulfillment center to store and a pickup location instead of making a last distance trip to get product from the factory to people's homes. So, driverless truck technology classification. So now the question then becomes what levels of autonomy can be adopted in commercial truck nowadays? Then when should each be adopted? The current state of federal policies and regulations for the autonomous trucking market are largely absent, making integration across full network difficult. Let's see what level are in self-driving truck now. So now we have autonomous feature at level 1 and level 2. So this change includes small shift toward increased driver assistance. In many cases, this technology can be seen in both passenger vehicle and heavy truck duty trucking on the road. Level 1, for instance, can include adaptive cruise control and lane assist feature. Technology at level 1, however, is implemented independently of other autonomous features. Level 2 involves two primary control functions working together. Leading-edge companies such as Peloton and Tesla have implemented this level of automation in prototype fleets. Level 3 is where automation start to become more intensive. Fully autonomous solutions begin to emerge in instances where highway driving is consistent and predictable, like long-haul routes. The driver chooses which automated feature to employ and most miles are traveled autonomously, but the driver maintains the ultimate control of the vehicle throughout the whole drive. Instance where driver intervention is required include a very bad weather event that limit connectivity and visibility, and more variable urban and city driving that require frequent starting and stopping the car. Level 4 automation is similar to level 3 in that the driver is still present, but at this level, the vehicle will be operating fully on its own in all scenarios. Most companies are jumping level 3 and striving for level 4 right now. For example, Waymo is testing level 4 technology within their own business but have yet to move into the commercial sphere. TuSimple, founded in 2015, is another market leader that is testing automated vehicles at the higher levels of automation. TuSimple operates 200 trucks in the United States and 500 global trucks over millions of miles of testing through 2019. And now comes the level 5. It's perhaps the furthest from the reality of today's trucking industry. Humans will no longer be driving trucks or even present, and vehicles will be fully automated. Level 5 automation is more prevalent overseas, especially in Sweden, where two companies in Wright and Volvo are testing level 5 technology in controlled low-speed, short-distance environment right now. So, with the rapid developments of autonomous truck, there are already lots of good news on the internet right now. So, in June 2021, the company based in San Diego, TuSimple, is conducting depot-to-depot supervised autonomy tests run in Arizona and Texas in partnership with Navistar and UPS. The supervision includes someone riding in the cab in case they need to take the wheel. On March 2022, during the course of more than 5 consecutive days, a self-driving 18-wheel transported goods between the cities of Dallas and Atlanta. It operated non-stop for 24 hours, lodging over 63,000 miles travel, completing full circuits and transporting 8 separate loads of cargo. On June 2022, in U.S. pilots program, there are some autonomous trucks have already driven on public highways. This test vehicle either have a safety driver in the cab to take over in case of problem, or were followed by a mobile assistant. On August 2022, on a Wednesday night in August, a purple and white truck left a suburban grocery store and drove 7 kilometers to the low cost limited company and the headquarters in Brampton, Ontario, which is west of Toronto. So now we're going to talk about concept development stage. This stage question and answer the need for a new or replaced system. It involves analyzing and planning the new improved system and its feasibility. Thus, this requires to take into consideration various factors such as stockholders' need, practical feasibility, budget cost, scalability, and etc. Since this is an initial stage of the system engineering development life cycle, it is very different from the rest of the stage. It also involves understanding of the interaction between the system and external environment and the internal interaction. System engineering helps in converting operational needs into an economically and technically viable solution. Concept development further can be classified into three substages. First, we need analysis. Second, concept exploration. And third, concept definition. We will understand the concept and viewpoint of establishing self-driving truck into our transportation system. The concept development stage of self-driving truck and for any system engineer project will provide valuable information needed to carry out the corresponding parts of the system engineering life cycle. Okay, so need analysis. This is the primary objective of need analysis is to show that there is valid operational need as well as strong and open market for autonomous truck. We must analyze the pros and cons the system offer with respect to its predecessor and needed to be fully aware whether the system bring any value within a budget and a few thresholds. From the analysis, we can see that due to industry pressure from rising delivery demand and driver shortage, as well as straightforward operational domains such as highway, this intelligent truck may be the first autonomous vehicle to hit public roads at scale. In the very beginning development stage of autonomous driving, it has helped the vehicle drivers and passengers as one of its final mission. For example, collision avoidance, stability control, and lane departure warning system that are developed and operated within the autonomous driving technologies, which are very helpful for the truck drivers and turn the driving large vehicle to be much safer. Compared with the ordinary auto driving system, auto driving technology of truck could be capable of preventing any harmful driving behavior, including speeding and fatigue driving. It is possible that the road traffic safety would be improved to some extent when these autonomous driving technologies are popularized. Although autonomous driving technology still had its limits and it could hardly prevent accident under certain circumstances involving the specific weather and road conditions. However, many system engineers state that the autonomous trucks will greatly reduce accident compared with manually driven truck. According to the report released by the McKinsey Global Institute, autonomous driving technology is expected to reduce traffic accident mortality by approximately 90%. So for concept exploration, the result of concept need analysis is a stage get carried over into the concept exploration stage. Every step of system engineering necessitates this transformation from a purely operational to purely technical perspective on the system. This step involves giving the user a wide variety of options to choose from, and the abstract notion that can be developed into a stage into actual world. Numbers of infrastructure and functional modules are required for this stage. Um, System engineer need to break the process of concept exploration into four distinct steps in order to bring the concept of driverless trucks one step closer to the reality. There are various requirements such as in-depth to analyze the operational and performance requirements and a well-designed new system or model. What is more, a technology driven system is created by a system developer who is knowledgeable about the technology would be more ideal. So for concept definition, system engineer will have to think about the several issues they will probably meet when the engineer designing and building the autonomous truck due to several objective aspects including the operational performance, program cost, and schedule conflict. Trade-off would be a reasonable option for us. Furthermore, risk is another significant aspect which will be taken into consideration. Moreover, system engineers would use two tools involving test and feedback to improve the autonomous truck. Except these two tools, test and feedback, measurement, observation, and estimation will be used to have develop and validate autonomous truck too. This phrase not just Intel selecting from autonomy system concept described in concept exploration as the basis for the future research in engineering. But this phrase also began work on the new system functional and physical aspect that used for system development. On the ground, multiple case studies must be undertaken to determine the best option depending on operational performance and compatibility. Second, the program budget. And third, program schedule. And the third, risk. So now let's discuss all these factors in details. When designing and building the self-driving truck, the engineer need to give some thought to the various problems that might encounter in the process. The operational compatibility, the cost of the program, and the schedule conflict are all objective factors that need us to make a trade-off. Another major factor that would be considered is the potential harm will occur in the development. There are lots of options available, such as measurement, observations, and estimation we use to build and test the driverless truck. Despite the safety of autonomous truck is able to be improved by using two tools involving test and feedback, the importance of safety cannot be overstated. Engineers should hold ourselves and each other to high safety standard in trucking. Whether it's running a simulation, testing the software and hardware, or putting the truck out on the road, this standard apply regardless of whether the trucks are self-driving or not. So now we're going to talk about engineering development stage for autonomous truck. After the concept development stage, here comes the second most important stage, which is the engineering development stage. As part of this process, we chip away at the most pressing requirement identified during the concept development phase. In this phase, we will put together the design strategy and develop the framework by creating a prototype of the system and then rigorously testing it until it is ready for real production. And we will go through the stage with the three substage below. First, the advanced development. Second, the engineering design. Third, integration and evaluation. So, from my perspective, um, the advanced development step is to find out the possible uncertainty of the new component and that introduced to apply in the whole system through analysis and development in advance. Compared with any other development step, advanced development step is quite significant because of the risk of management, which is to validate the feasibility of the system design. Since the system, including several subsystems and components, could be extremely large and complex, nobody could ensure that every change or modification is always suitable and positive for the whole system. During this step, the main purpose is to resolve most of the uncertainties to optimize the whole system by using trade-off analysis. For autonomous truck, it consists of lots of unknown technology from both hardware and software aspect. Since the development of autonomous truck is one of the most cutting-edge technology using so many unknown technology on Earth, no one could foresee or predict what would happen during the experiment. For example, LiDAR sensor is the very first time to be introduced into the development of autonomous vehicle. In the very beginning, system engineers have some trouble to tackle the data from the LiDAR sensor since most of the data is not relative to the autonomous driving at all. System engineers will have to think about the potential issues of using leaders and prepare for the alternative plan during the advanced development step. Thus, according to advanced development step, system engineer could do the assessments of the maturity of each component in autonomous truck to make sure that every subsystem would work properly. Furthermore, prototype development for the autonomous truck is another another for the autonomous truck is another crucial element we need to discuss in this phase because of high levels dependability in harsh conditions is assumed when applied to the development of self-driving truck. Reliable connectivity serves as a crucial block. After completing the advanced development step, system engineer will have to consider about the engineering design step. During this step, system engineers are supposed to deal with the issues that are identified and found in the previous step, the advanced development step. From my perspective, engineering design step is to set up several rules and test requirements to build an engineer prototype of autonomous truck, which is prepared for the future test. An engineer prototype would be set to test the reliability, maintainability, and productivity of the whole system of autonomous truck, which is to collect the information and data to design accessible to design for maintainability. The main purpose of maintainability is to make sure all components are accessible and simple. According to the textbook, we know that there are four system engineering considerations: that user interface, environmental interface, module design, and assembly issue. To take these four factors into consideration, system engineers are supposed to ensure that each component will be designed differently with independent failure behavior, which is called design diversity. For example, several subsystems, including the LiDAR sensor, onboard computer, and GPS receiver, will work and cooperate with each other to build the autonomous driving system. For each subsystem, it is made of lots of small components. If all these redundant components are not designed with different failure behaviors, system engineers would have to spend much more time on maintainability, which is inefficient and increase the cost of design. And so for the hardware, as I mentioned about, it is not simple to turn an unmanned vehicle into autonomous truck, especially with the support of hardware. It is possible for system engineer to make a great progress on the developments of autonomous truck, which might allow the unmanned truck to realize the L4 level autonomous driving. Since the autonomous truck is a typical example of system engineering, it is made of outstanding software system and hardware system. In addition to software system and hardware system engineers are supposed to pay attention to the mechanical aspect to meet the electronic requirements and the issues of hardware requirement as well. During the concept development stage, we know that a lot of sensors have been introduced and applied in the autonomy vehicle. Nevertheless, all these sensors will not operate at the same time since the onboard computer will only choose a suitable one and make the plan efficiently. Thus, it is not necessary to put all the sensor on the same types of vehicle, which depends on the need. For instance, if the system engineer only want to achieve the autopilot on the highway, an urban road that is quite similar with the Tesla autopilot function, a laser sensor might be not necessary at all. Therefore, during the engineer design step, the test of autonomous driving system must be really task oriented. So system engineers should set up demarcation line to validate in hardware case by case and use the trade-off strategy to control the cost. According to discussion I mentioned above, multiple substantial mind apply a large amounts of information and data for the onboard computer on the autonomous truck to analyze. Powerful software is required to play as one of the most significant part in the whole system. During the engineering design step, we know the system engineer will focus on the design diversity and design on maintainability. So a remarkable software would turn the maintainability to be more effectively and reduce the cost as well. For instance, the software part of an autonomous truck is mainly made of four layers: that perception, fusion, decision making, and controlling. For the perception layer, the autonomous truck would use the software to collect the image information from the camera and is transferred to the fusion layer. For the fusion layer, the image information will be classified and processed. The software will only select the useful part to transfer to the next layer, that decision-making layer. For the decision-making layer, the system would use the algorithm to analyze the image information and make a plan involving the vertical and horizontal control for the autonomous trucks repeatedly. After making a plan, the decision-making layer will send a signal to the very last layer, the controlling layer, which is to make the autonomous truck to take action and work independently. With the support of the advanced software, autonomous truck will make a decision and pick up one of the best solutions offered by the onboard computer and execute them rapidly. For integration and evaluation, the biggest reason for us to create autonomous truck is to mitigate the truck driver shortage and significantly reduce traffic fatalities and injuries. While it is evident that in the coming years and decades, the autonomous truck will transform the trucking industry, it still takes longer time for autonomous truck to handle all the driving tasks than we expected. With the rapid development of autonomous trucks, there's increasing numbers of companies such as Google, self-driving car projects, Waymo division, and so on are trying to invent an autonomous driving system for self-driving trucks. It is exciting that Waymo already started to operate autonomous truck in Atlanta, transporting server equipment and other material to the Google data center. What's more, there are lots of companies like Uber, TuSimple, Embark, and so forth that have been conducting tests on highway. Although there are still safety drivers behind the wheel for the time being for safety issue, in the meantime, there are more and more manufacturers and suppliers are investigating the possibility of getting into the autonomous truck business. It is likely that new technology adoption will proceed at a slow and steady pace, even though the technology is ready. Not only government need to take time to set up regulation, but also the truck manufacturer will take time to manufacture the trucks that are equipped for autonomous operation. Initially, the autonomous truck will need to share the road with a human driver. It is anticipated that autonomous truck will have a rapid uptake once the accessibility is improved and the safety record is certified. Especially if the government can support the autonomous trucking system, that would be greater share of the self-driving truck on the road. Even though when integrating the autonomous driving system into the existing network, there will be a need to take into account the impact on the other service already in place to avoid disrupting the network's equilibrium. However, there's no doubt that autonomous truck can bring various positive aspects to our society, such as improving efficiency, reducing costs, enhancing economic value, and optimizing on-demand service. So when we come to this phrase, the post-development phrase, it means the life cycle of system is about to come to an end. So far, the autonomous system has been completely engineered, developed, and validated, and it is ready to move on to the next stage. More specifically, the system engineer plays an important role in this stage because a multiple parts of system need periodic updates, upgrades, and maintenance. And post-development stage consists of two essential components. First, production, second, operation and support. So for the post-development stage, production step of autonomous truck plays an important role, which is mainly to focus on efficiency, economic, and product quality. Before the mass production of autonomous truck, increasing details are required to be ensured and considered. Overall quality control is a critical factor that is relative to both customer and manufacturer. From my perspective, two factors of quality control that driving system and driving comfort are necessary to be considered. First of all, driving safety is always a significant principle for the autonomous truck. A complete autonomous truck must comply with the traffic route, which is to provide the user with the navigation in multiples of um, driving situation. Even though the driving situation might be unexpected, it is the mission for the system engineer to finalize the vehicle, tackle the issues, and ensure the reliability for the customer. For example, a small software error might be fatal in the whole system and that might cause the car accident. That is the reason why system engineers need to validate the autonomous truck during the integration and evaluation step very carefully. Um, so for operation and support step, it is the very last step of post-development stage of autonomous truck the system engineer will go through. Before the commercialization of autonomous truck, a large number of work involving operation issue and maintenance guarantees still need to be done. First of all, we will talk about operation issues. Compared with the traditional faults location and issues of slow response speed, a new way that a real-time fault discovery is introduced into the market and widely used in different manufacturers. With the development of 5G network, the latest monitoring center that is connected with multiples of edge service is capable of collecting the data, analyzing the issue, and giving a solution instruction in few minutes, which increase the efficiency of maintenance process. System engineer will not have to check every part in the system one by one any longer. All components in the system will be classified as different modules with different color. If there is something wrong with the autonomous truck, the monitoring center will record the issue, mark the issue as an error, and send an alarm to the system engineers. So for challenging, there's still a long road to autonomous trucks. Although there already has some breakthrough news all over the internet. For example, self-driving in some states such as California and Texas, it is now legal for 18-wheeler to drive on highways. On the other hand, there are still human safety driver operating the vehicle, and what would it take to get them out? Developing autonomous driving system is difficult enough, especially if we need to integrating it into the current transportation system we have because it's really expensive to building a new infrastructure just for autonomous truck. And deploying such vehicle in the real world in a way that is both commercially viable and safe is still another obstacle. Needless to say that the testing of operating autonomous truck in today's world are severely hampered by the restriction by different states. Like different states, they have different rule for transportation. And what is more, deploying this truck is also a logistical change that will call for significant change to be made throughout the trucking industry as a whole. From the news we mentioned earlier in the background section, Korea truck did not enter either the city during its delivery service between Dallas and Atlanta. It exited the highway at convenient location to drop off its load and fill up its fuel before heading back. After that, regular delivery truck pick up the goods and complete the final or last mile of the journey. First, deployments of autonomous truck. First, business must establish a system of this transfer hub in order to implement widespread deployments of autonomous trucks. However, it is really expensive to build this kind of infrastructure from scratch. Thus, self-driving truck companies are seeking the ways of working with the existing infrastructure. So, a renovation in human transportation may be on the horizon in the coming decade, thanks to recent advances in research and the beginning of the commercialization of self-driving trucks. Some people argue that self-driving trucks should be viewed as separate and distinct from their human-driven counterpart if the widespread adoption of the autonomous truck is to be considered a renaissance. It is exciting that the first fully autonomous trucks are entering production after years of research and development. Uber, Waymo, and other tech companies are at the forefront of this movement. And even the auto car manufacturers like General Motors and Ford are also working on the autonomous system. It is well known that freight shipping businesses are always looking for ways to improve their operations so they can transport more shipment but with less memory. With this demand, tech companies like Mbot are creating trucks that are making significant progress toward full autonomy. To strengthen transportation and public safety, companies are coming up with a plan. Autonomous trucks would normally operate autonomously while on the highway, but a professional driver probably will drive the truck at the beginning and the end of the road. The trucking industry is expected to benefit from autonomous driving technology in the forms of increased productivity with the help of self-driving trucking technology. The business could transport more cargo every day with the same numbers of driver or fewer drivers than right now. Additionally, autonomous trucking technology could mitigate congestion during rush hour if autonomous trucks would allow to operate during less busy times, since trucks and computers they never get tired like human drivers. However, there are still lots of cons to autonomous truck. Firstly, autonomous truck technology is still not mature and it will be very expensive to build a new infrastructure for the new autonomous truck. And also, there's another concern is the insurance and the legal responsibility for accident. So if a accident is caused by autonomous truck, like who should take the responsibility and who can be held responsible if autonomous truck is responsible for someone's death? There are still a lot of problems that have not been overcome, and it will take some time to find a solution for all those problems. So, system engineering, a multidisciplinary field, is the process of creating functional systems. Designing and managing complicated systems over their lifetime is the main focus. There's no doubt that complex and large-scale projects will have lots of challenges, such as logistics, collaboration, testing, and assessment, design, and reliability. System engineers need to deal with optimization method as well as risk management for the plan to be successful. With a deeper understanding of the strategic goal of the organization interface challenges and impacts, engineer can better be managing and control costs and schedules. This is the first time I learned the concept of system engineering and it is mind-blowing for me. I never taken thought of how we come up with the complicated transportation system that we are having right now. After this class, I truly understand the whole process of how engineers come up with the complex systems. And this class helped me think outside the box and helped me approach the issue logically and method. methodically. Furthermore, it is fascinating to learn about the development of autonomous trucks and makes me want to join the autonomous trucking company to develop the technology. I learned lots new concept in this class and it will benefit me throughout my careers. And this is and thank you so much for listening.